Hello, I'm Kevin Bean, Product Marketing Manager for Gleaner and Massey Ferguson Combines for AGCO Corporation. I've been at a lot of farm shows over the years, and I've had a lot of customers come up to me and say, tell me the difference between the transverse natural flow combines and other axial type design combines. And the question that seems to run through my mind is, how do you get all that material through that narrow feed opening on that natural flow R-Series combine? So I wanted to take a moment today, if I could, and just kind of walk you through a little bit of some of those concepts that we're trying to do as we try to give you the smoothest, most highly productive combines as far as feeding is concerned in the industry today. So let's take a moment. I'll walk over here to the whiteboard and show you some things that maybe you didn't look at as you look at combines and understand what really goes on in that natural flow R-Series combine versus competitive axial type designs. First of all, I wanted to take an opportunity to start out by saying that, first of all, when you look to the front of the feeder house opening, what you will notice here is in the R-Series combine, it roughly measures about 40 inches across the width of the feed opening. And with that feed opening there, we actually feed that material as a very smooth, even crop mat. And one thing that is unique on the R-Series combine is that we maintain the width of that crop mat from the time that it enters that feeder house to the time that it enters the actual rotary processor itself. This is what makes it so unique. If I'm able to maintain that width of that crop mat evenly and all the way into the feed opening, that means that I have no pinch point or any bottleneck that can occur in competitive axial combines that I'll allude to in a few moments. So what we do here is we're feeding the material evenly across the entire width of that feeder house. We bring it up into the rotary processor, and across our 90-inch fully perforated all the way around rotary processor cage, we actually are threshing the entire circumference of that rotor. So even though it's a 90-inch width rotor, it actually has a capability of threshing the equivalency of 180 inches, or double the actual width of the machine, simply because I do not have a cover over the top. It is open and it's perforated all the way around, so I am entirely threshing the entire circumference. By doing that, I accomplish in one pass what it takes all other competitive axial rotors 2 passes to accomplish, because all other competitive axial rotors are covered up at the top. So they might have a 160-inch wrap, or they might have a 180-inch wrap. But whatever that wrap is, they are not threshing the entire circumference of the rotor as we are doing in the transverse design. Now let's walk over for a moment and take a look here, if we can, at the axial combines that are out on the market today. You will notice their feed openings are anywhere from 50 inches to 55.4 inches. So we obviously bring in a very wide crop mat, but the real challenge that we have in an axial machine is we've got to take that very wide crop mat and we've got to figure out how to bring it up and actually feed it in to the intake area of an axial rotor. The diameter of that axial rotor in almost all machines out there in the market today ranges anywhere from 27.5 inches to 31.5 inches. Now, the challenge you have is being able to get that material in and reorient it into the intake area of the axial rotor. We accomplish that in a number of combines out there with what we call beaters, or some kind of helical vane conveyor feeding system that is unique to our axial combine. And that is in order to take that material and squeeze it down and get it started into that intake area. This area is where the challenge is for all axial combines, because this is a natural pinch point area where, again, it becomes a bottleneck that you try to have to navigate through and try to do the best you can to get that material feeding into the processor. You can see here very quickly, as you go back over here to the transverse, that there is no bottleneck. It's a natural feeding process. And the advantage is we're not squeezing the material down as we have to in an axial machine. We're able to take that material and actually feed it in and keep that width and keep that material moving in a ribbon-like effect across the processor. Obviously, both designs give obviously great capability and capacity, but we feel the natural flow design gives us an advantage, again, of eliminating that pinch point, that bottleneck, and enhancing throughput capacity. And that kind of gives you a little bit of an understanding, I hope a better understanding, of why we think the very unique transverse R-series natural flow process gives a tremendous amount of capacity. And it maybe changes that thought you had about the fact that it's all about how wide the opening is. It's really about how you convey the material through that processor, and again, not changing the width of that crop mat and making it a natural flow feeding process. Thank you.